launch.
Falcon 9's in startup.
Dragon is in countdown.
Both stages are now pressurizing for launch. Range and weather should both be good to
Falcon
go.
9, CRS 23, go for launch.
That was the voice of the launch director verifying we are go.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Cargo Dragon takes flight, continuing a busy year of deliveries to a crew of 7 aboard the International Space Station.
Stage 1 chamber pressure is nominal.
Falcon 9 has cleared the tower and is currently headed to space. In about 15 seconds here, we're coming up on max Q. This is where the vehicle will experience the highest amount of aerodynamic pressures. And there was the call out for max Q. We actually throttled down the Merlin engines in preparation for that event. Coming up are 5 more events in rapid succession. Main engine cutoff, stage separation, first stage flip, second engine start 1, and then the boost back burn on this first stage will begin. Main engine cutoff, also known as MECO, is where all 9 M1D engines on the Falcon 9 first stage will shut down. This is followed by stage separation, or the separation of the first and second stages. From there, the first stage will flip to prepare for re-entry and landing a few minutes later, and the Merlin vacuum engine on the second stage will ignite to boost Dragon to low Earth orbit, and that's also known as SES-1. The first stage will then begin its boost back burn. That is the first of 3 burns needed to land on our drone ship today. The first of those 5 events, main engine cutoff, is coming up in about 10 seconds.
Main engine cutoff.
Stage separation confirmed.
INVAC ignition.
Stage 1 boost back burn startup.
Okay, those were those 5 events. A lot happening on screen. Main engine cutoff, stage separation. The first stage performed a flip. Second stage on the right-hand side of your screen ignited its Merlin vacuum engine. And on the left-hand side of the screen, we're in the middle of that first stage boost back burn. Looks like we are getting some really cool views
Stage 1
of
boost back
the
shutdown.
contrails being produced by the first stage. And that was the call out for the successful completion of our first of 3 burns on the first stage. So if you're just joining us, you're watching a live webcast of the 23rd commercial resupply mission to the International Space Station for NASA. This is SpaceX's 21st mission this year, and this is the cargo configuration of our Dragon spacecraft.
Acquisition of signal at Bermuda.
You might be interested to know, in order to get into space, the rocket has to do more than just go up. It actually has to go sideways really, really fast. At liftoff, gravity is pulling straight down the rocket, and as we ascend, we tilt the engines. That turns the rockets horizontally. Now, we're still going up, but we're also heading horizontally away from the launch pad in what we call a gravity turn. The rocket typically needs to go about 7.5 kilometers per second, or 17,500 miles per hour horizontally, in order to avoid being pulled back down to Earth and get into orbit. On screen again is the view of the Merlin vacuum engine on the second stage. On the opposite end of that engine is our Dragon. Next event for today's mission is the re-entry burn for the first stage. That's the second of 3 burns. This is where 3 of the Merlin engines will reignite, and this helps to slow down the stage as it re-enters the upper parts of the Earth's atmosphere. And that the beginning of that burn is happening in just under a minute. Seems like we've lost the video footage of the first stage. Hopefully we can get it back in order to see that re-entry burn. But on the bottom left-hand side of the screen is a speedometer of sorts tracking the velocity of the first stage. As we begin that second burn, watch for that speed to slow down, and definitely once we hit the denser parts of the atmosphere, we'll start to see the speed slow down quite significantly.
Stage 1, entry burn startup.
And there is the beginning of the entry burn. 3 Merlin engines have relit and are currently slowing down the first stage.
Stage 1, entry burn shutdown.
Awesome. That is the successful completion of the second burn. We are about 60 seconds away from landing, and the vehicle is traveling about 900 miles an hour. This really puts into perspective the deceleration. In the span of less than a minute, we'll have reduced the speed from the speed of a jet all the way down to 0 as the rocket lands. And again, this is our brand new drone ship, a shortfall of Gravitas. This is going to be the first time that we are making a landing attempt on it, and it's currently perched out in the Atlantic Ocean waiting for that first stage booster to return to it.
Stage 1, landing burn startup.
A single engine, the center engine, engine number 9, has relit in preparation for landing.
Stage 1, landing leg deploy. Stage 1, landing confirmed.
And that is the 90th successful landing for an orbital class rocket, and the very first for our new drone ship, a shortfall of Gravitas. That is a beautiful thing to see and a great way to start off today's mission. Next event coming up is for the second stage. The Merlin vacuum engine will shut off its engine in an event called Second Engine Cutoff, also known as SECO. And shortly after SECO, we'll be entering a coast phase and waiting for that confirmation of a good orbit.
SECO.
Nominal orbit insertion.
And we did get confirmation of both SECO, second engine cutoff, and a nominal orbital insertion. Now, the second stage has one last major task, and that is commanding separation of Dragon a couple of minutes from now. Again, this is the second flight for this particular Dragon and the first reuse of our upgraded cargo vehicle. We should have video of Dragon separation from the top of the second stage. It'll give us a nice view into Dragon's unpressurized cargo trunk. And when this Dragon makes its way to the International Space Station, it will be joining the Crew 2 vehicle Endeavour, currently on orbit and attached to the International Space Station. It's going to be super cool to see two Dragons dock to the International Space Station once again. And again, for cargo, we will be delivering over 4,800 pounds of science, research, crew supplies, and vehicle hardware to the orbiting laboratory and its crew. This includes the brine shrimps and ants that we had talked about earlier in the broadcast. Now, the science and research being done in microgravity on the International Space Station has benefited our lives here on Earth for decades. What's really cool is that our new Cargo Dragon vehicle is also able to act as a laboratory in the advancement of this science and research. We call this capability Extend the Lab. It allows some powered payloads to remain on Dragon for experimentation during the duration of the mission. This is especially helpful when there is limited to no space on station for additional science, and it also helps cut down the amount of time the crew has to move payloads in and out of Dragon. For CRS-23, there are 3 Extend the Lab payloads launching with the mission, and once docked, a 4th, which is currently already on the space station, will be added to Dragon. So we are about a minute away from that separation from Dragon from the second stage. For now, we are enjoying some views of the second stage Merlin vacuum engine. We can talk a little bit about the upgrades that have been made to Dragon. The first is solar arrays. Typically, after separation, we wait for solar arrays to unfurl from Dragon. This upgraded Dragon has been redesigned, and the solar arrays has its panels built into the trunk section itself, providing power during flight and while on board the station. Another upgrade is how we dock. Before, we needed Dragon to be berth, which is where a robotic arm from the International Space Station reaches out and grabs Dragon and will attach it to the International Space Station. Now, Dragon can autonomously dock using a centerline camera and LiDAR, which is an acronym for light detection and ranging. And so this autonomous docking sequence is what Dragon will go through in the short future as it continues to make its way towards the International Space Station.
Separation confirmed.
And that is a great view of Dragon separating from the top of the second stage. Now the service section Dracos will undergo some checkouts. Coming up is the beginning of the nose cone opening sequence. I'm going to hand it over to Shaniqua